Welcome to Water Resources Engineering class. In the previous lecture, we learnt about how to measure the precipitation, whether it is a non-recording rain gauge or recording rain gauge, how to present the rainfall data. And in today's lecture, focus on the estimation of average precipitation. While calculating the average precipitation or mean precipitation or in turn mean rainfall, what are the methods to calculate the average precipitation? And there are three methods which we are using. One is arithmetic mean method, second one is Thiessen-Polygon method, third one is isohydral method. So let us focus on these three methods and then let us see the comparison along with some more problems in those three methods actually. Let me take straight away the methods. One is arithmetic mean method, the other one is Thiessen-Polygon method, isohydral method. The arithmetic mean method is mainly used for flat areas, very important. That is mainly used in the flat areas, normally where we expect uniform depth of rainfall. So in that, actually what we do in the arithmetic mean method, for example, this is the catchment. So there may be rain gauges like this. So here 1, 2, for example 3, 4, 5, 6 rain gauges. So what I do in the arithmetic mean method, what is the rainfall here, what is the rainfall here, sum up. Just I take the sum. If I take the sum, that is enough. So if I take the sum of it and then divide it by the number of stations. If I put it, that's what arithmetic mean method is. P1 is the rainfall at the rainfall station 1. P2 is the rainfall at the rain gauge station 2, 3 and so on for n gauges divided by n. So this is how we calculate, especially by arithmetic mean method. But this method gives fairly good results if the rainfall distribution is more or less uniform, if the area that which we are choosing is completely a flat area. Coming to a small example, let us take it. We have actually 4 rain gauge stations here. In these 4 stations, the rainfall values are also given. And I need basically what is the average rainfall by using arithmetic mean method. Just sum up it, number of stations, sum divided by number of stations will give you the solution. Then now see generally how the catchment looks like. This is a catchment. So how many stations are there if you look into it? There are 11 stations in this. And at these 11 stations, what is the rainfall also it is given. So now how you get the average precipitation? Sum of all the things divided by 11. So naturally you are getting the average precipitation. Suppose you go to the Thiessen-Polygon method. In the Thiessen-Polygon method, what we will do is, you suppose for example this is the catchment. Now for example you has 1, 2, 3, 4, 5, 6 rain gauges. Let us take it. What we will do is I call them as 1, 2, 3, 4, 5, 6. Then what we will do in this, first join the rain gauges actually. See how I am joining. Join the rain gauges first. I have joined. Then draw the perpendicular bisectors for each of the things. So if I draw for 1 and 2, this is the perpendicular bisector. For 1 and 3, I can draw the perpendicular bisector. And similarly, if I draw 3 and 5, I can draw it. Similarly, 2 and 4 also I can draw that actually. Similarly, 4 and 5, 4 and 6 also I can draw a perpendicular bisector. And similarly, I can draw 5 and 6 also a perpendicular bisector. So like that, if you draw the perpendicular bisector, for example, under the rain gauge station 1, now this is the area. Why perpendicular bisectors? Because the perpendicular bisectors gives the area corresponding to that rain gauge, because that is the nearest area to that rain gauge. So if for the rain gauge 1, this is all the nearest station. Similarly, for rain gauge station 2, if I take it, this is the nearest area. For the rain gauge station 4, if I take it, so this is all the nearest thing. For the rain gauge station 6, if I take it, this is the nearest area. Suppose for the rain gauge station 5, this is the nearest area. For the rain gauge station 3, this is the nearest area. So now what I will do, by drawing the perpendicular bisectors, I really find out what is the area corresponding to each rain gauge. So each rain gauge corresponds to which area, so that I calculate. So once I calculate that area, actually the rainfall multiplied by that area, right? Rainfall multiplied by that area, so like that I sum it up, divided by what is the total area of the catchment. Exactly the same I have written if you see it. Plot all rain gauge stations on a map. Join the adjacent rain gauges by a straight line. Draw the perpendicular bisectors between the gauges to create polygons. Why this method is called as polygon method? Thyssen polygon. We are creating polygons. Each of these things is a polygon actually. Create those polygons. Measure the area of each of these polygons actually. Multiply rainfall at each station by the area of its polygon, right? Then add all this and divide it by the total area. So that's what just now I explained. And if you want it in terms of a formula like thing, if I want, I have written it as sigma of I is equal to 1 to n, where 1 to n is the number of rain gauge stations. Pi is the rainfall value at I station. Ai is the area at the ith station. And if you do total and divided by the total area, which you can get the combining all the areas, you will get the total area. So this is what actually the Thyssen polygon method. Mainly the Thyssen polygon method is definitely more accurate compared to the previous one, the arithmetic mean method. But actually the only difficulty here is it is to calculate the area. So that is one thing which you should remember. Allocation of areas, that is also called as allocation of weightages to each of the rain gauges. How you allocate the weight factor for each of the rain gauges, that is very important. What is that weight factor also? Let us see that also. I will show you with the help of a problem what is that weight factor. So here also you take it, now they have given actually the rainfall values and respective polygon areas. So station ABC, 3 stations only he has taken the rainfall values, and this is that probably this is the areas. Area in kilometers square, you can take it actually, this is the thing. Calculate the average rainfall using the Thyssen polygon method. First what I have done, multiply each station's rainfall with area, because he has given the area. If he has given the area, simplest method, normally what will happen is they won't give the area, only they give the shape. Or otherwise if you go practically into the field, normally the catchment is so irregular, so we need to calculate the areas using planimeter. So kindly remember that the only part is where attention is required in this method is calculation of the areas. So now you see it, rainfall multiply, this is the rainfall area, rainfall area, rainfall area. Now add this sum value, you will get it. Now divided by the total area. So step 2 by step 3 will give you the answer. This is what the problem is. Now another way of looking at the problem is like this. This is general way, one way. But what is the other way of looking at the problem is express the weight factor bringing into it. So the weight factor means how much is the weight for each of the rain gauge station. How much is the area is, that means is given to the each of the rain gauge station. So that will be generally expressed in percentage. What is that? So this is the area of a particular, what you call it as the rain gauge. They are corresponding to a particular rain gauge, and this is the total area. So if I am calculating at rain gauge station, for example, now if I take it, this is the area and these are the 1, 2, 3, 4. Now I have taken actually connecting these 4 actually, for example, like this I have connected. Then if I draw the perpendicular bisectors, this is the perpendicular bisector. So this is the area corresponding to the rain gauge station 1. So this A1 divided by the total area is what we call it as the weight factor for this area. That is the weight factor. Similarly, A2 divided by total area is the weight factor for this particular rain gauge. Similarly, A3 divided by total area is the weight factor for this area. Similarly, A4 divided by A is the weight factor for this. So like that you can calculate the weight factors, and once the weight factors are found, weight factor multiplied, suppose this A1 by A is called as weight factor 1. A2 means this is the weight factor 2, weight factor 3, weight factor 4. So naturally how you get it actually, this weight factor 1 into the rain gauge station 1, the rainfall at 1, plus weight factor 2 into basically this, what you call it as rainfall at station 2, plus weightage factor 3 into rainfall 3, and weightage factor 4 into rainfall at 4. All this, if you add it up, you get the average precipitation. You get actually the average precipitation. So kindly remember, the average precipitation in Thiessen polygon method can be obtained by 2 ways. So both ways are same only a little bit explanation difference. In the first method, what I told actually, first join the rain gauges, fine. Draw the perpendicular bisectors, fine. Then allocate the allocation of each area to each of the rain gauge stations, fine. Find the area corresponding to each of the rain gauge station, fine. Then once this is determined, then what I told, just simply P1 into A1 divide plus P2 into A2 plus P3 into A3 plus P4 into A4, like that any number of rain gauges are there, that much divided by the total area. That's all what I mentioned. But here what is the crucial step? Determination of the areas, allocation of the areas, contribution of the area to each of the rain gauge station. Then coming to what is the second one I told? Just weightage factor. How you find the weightage factor? What do you mean by weightage factor? Just what is the area under each rain gauge? That area under each rain gauge divided by the total area is nothing but the weightage factor. Then from that weightage factor, what is the use? The weightage factor multiplied by the rainfall at that rain gauge station will give you the contribution of that particular rain gauge station to the average precipitation. Like that, if you calculate whatever the areas are there, then total, if you add up, just that gives you the total average precipitation. So this is another way of looking at the thing. So let us see also. I have taken a problem just for your understanding sake. Now there are how many stations are there? You see 11 stations are there. Now you see the figure actually. We have joined the rain gauges first by dotted lines. So now if you take it, these are the perpendicular bisectors actually. So in the perpendicular bisectors, if you see it, why we have drawn the perpendicular bisector? Only to allocate the areas for each of the rain gauges. When I am doing that, for example, rain gauge station 1, so this is the basically area under rain gauge. Similarly, for rain gauge station 7, this is the area which we have allocated. For rain gauge station 2, this is the area which we have. Rain gauge station 10, this is the area which we have allocated. Rain gauge station 6, this is the area which is allocated. Rain gauge station 5, this is the area. Rain gauge station 9, this is the area. Rain gauge station 11, this is the area, and rain gauge station 8 is this is the area. So like that we have allocated areas to each. That's what exactly all this is, the rainfall, rain gauges, the areas under each of the rain gauge. So this is being given by him at each rain gauge station. What is the precipitation that he has given? Now areas from these polygons we have found. Then weightage factor is nothing but suppose if you take it, this area 22 divided by 1944 is nothing but this is the A thing. Actually like that, if suppose you take 62 divided by 1944 into 100 will be 3.19. Like that 254 divided by 1944 is equal to 13.07. So all that total together, naturally it has to be 100%, right? Because all the areas put together, total area. So this is the thing. So now what I need to do, contribution of basically the contribution to each of the rain gauge station. So naturally what I do, this weightage factor multiplied by the rainfall, this is the answer. And contribution here 3.19 multiplied by this 48.1, this is the thing. Like that, for example, if 13.07 into 154 is equal to 20.13. All this if you add, this is the average precipitation. So by weightage factor you can calculate it, or you want other method. So this multiplied by this multiplied by this, you don't need to this fact at all. So everything you multiply all divided by total area is how much? 1944. That also will come to this only. So any method you can follow it. So this is the second method, Thiessen polygon method, definitely more accurate compared to arithmetic mean method. Let us go to the isohedral method. This is also normally mainly now we use actually for all the rainfall maps. We use the isohedral method for finding out actually the average precipitation. So what we do it is first we take the rainfall values, because the rainfall presentation is in the form of mass curve or in the form of hydrograph or in the form of point rainfall data. So from that data actually you plan the isoheight. What do you mean by an isoheight? Isoheight is nothing but lines of equal rainfall is what we call it as isoheight. So draw the isoheights on a map. When once you have drawn the isoheights, then what is the area between the isoheights you have to find out using a planimeter. So once you find the area of it, calculate the average precipitation of the pair, then multiplied by that into basically the area between the isoheight, and then all values and divide by the total area. What is that? Let us see. Suppose this I take the catchment actually. So this is one isoheight, 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 this is. So suppose for example, this isoheight corresponds to 10 mm of rainfall, and this isoheight corresponds to 20 mm of rainfall, and this isoheight corresponds to 30 mm of rainfall, and this may corresponds to 40 mm of rainfall. This may corresponds to 50 mm of rainfall. This may corresponds to 60 mm of rainfall, like that, right? Now what I need to do is take a planimeter, right? First thing is this. So I take it this as 0 mm, nothing. So now what I do is I measure this area A1. So A1 multiplied by, this is 0, this is 10 mm. So what is the average of these two? 0 plus 10 by 2 is nothing but it is equal to 5. 5 into this area A1. Similarly 10 plus 20 by 2, how much it will be? 15. So 15 into A2. So this is the area A2. Similarly next one is what? This is the A3. A3 how much actually? 20 plus 30 by 2. So how much it will be? 25 into A3. Then what it will be? 30 plus 40. 35 into A4. What is A4? This is A4. Like that you continue. Now add up all the things divided by the total area. So that if you put it, you will get the mean precipitation. So this is another method, and this is mainly used for the complex terrain where actually the topography is or varies. And second thing is Only problem with this method is you are drawing the isoheights is one of the most important thing. Isoheight is also nothing but isoheightal map is a contour map. Contour map in the sense that only thing is lines of equal rainfall we will take it. So that if you are able to draw properly, then this method gives you accurate results. So now you see, I will show you so he has given isoheights 10, 20, because isoheights when they are giving between two isoheights, this is the 10 is corresponding to one isoheight, 20 is corresponding to one isoheight. So between 10 to 20, what is the rainfall actually? 15 mm. And what is the area? 20. 20 to 30, what is the average rainfall? 25. What is the area? 35. And 30 to 40, what is the average rainfall? 35. What is the area? 40. Now what I should do it? So now if I take it, what is the average of these two? Automatically it is 15. So area is this. Multiply the average into this, because how you got this? This is nothing but average of this. How you got this? This is nothing but average of this. And how you got this? This is the average of this. Now what I will do? This multiplied by 20 plus this multiplied by, so 15 into 20 plus 25 into 35 plus 35 into 45 divided by, what is the total area? 20 plus 35 plus 45. That is what exactly I have done. If you see the step actually. So that is very simple method by using the isoheightal method. Then example also a little bit what you call it as the practical, how you think. So now I have taken this, if you have seen the figure, the same figure I have taken for arithmetic method, the same figure I have taken for Thiessen polygon method, and again I am taking the same method for isoheightal method also. So by taking this, we have drawn the isoheights. Now see the isoheights. Now how this isoheights data I converted into a table. How? Less than 30, right? That is area is this. 30 to 60 area is this. 60 to 90 area is this. 90 to 120 area is this. 120 to 150 area is this. Greater than 150 area is this. Right. Less than 30 means what I can do? Because if you see, almost it is closer to it. So we have taken it as 25. 30 to 60 means 30 plus 60 divided by 2, 45. 60 plus 90 divided by 2, 75. 90 plus 120 by 2, 105. 120 plus 150 by 2, 135. Greater than 150 means I have seen this area here. It is just corresponding to 160. So now what I will do? This area multiplied by that I have put. This area multiplied by the precipitation. Like that I have arranged each of the things. Right? After then sum it up. Sum divided by the total area I have put it. This is the sum. This is the total area. You got the answer actually. So this is how the average precipitation is obtained. Now the comparison. Arithmetic mean method accuracy is comparatively definitely low. Whereas uniform rainfall is there, then flat areas, definitely this gives us the preliminary answer and definitely we go for it. Thiessen polygon method, the unevenly spaced stations, then that is a medium level of accuracy. But isoheightal method, high, provided you draw the isoheightal map properly for any complex terrain or high rainfall variation. So this is the comparison between the three rain gauges. Now just to show actually in June 2025, very recent actually, the question that has come in some of the universities semester end exam I have taken. A basin has an area in the form of a pentagon. That is the first thing. Pentagon means how many sides? 5 sides, gentlemen. 5 sides. With each side length equal to 20 kilometers. This point is very, very important actually. The length of each side is same. If the length of each side is same, the problem doesn't take even 1 minute to solve that. That is the thing which every one of you should understand. If you say it is a pentagon, 5 sides, all 5 sides are equal. That is the second thing which you should understand. and internal angle is 120. So everywhere that angle, internal angle is 120, right? So that means it is almost a regular pentagon. It is a symmetrical thing. Every side is same. All the sides are same. The angle made inside is all same 120 only. The 5 rain gauges located are at the corners. Please note it. Very simple. At the corners A, B, C, D, E and their rainfall values they have given. Compute the average of depth of rainfall of the basin using Thiessen-Polygon method. Fine. So in the Thiessen-Polygon method, our problem is what? What is the area allocated to each of the rain gauge station? Understood? That is the critical thing. But this gentleman has mentioned it is a pentagon, right? And all the sides are equal. If you don't listen to that word, all the sides are equal and the angle enclosed is same everywhere, then naturally you will be taking much time. So naturally what you will draw. So if I draw the pentagon properly, for example, it may be in that sense. So one side will be there. This is also like this. This is also. Because all sides, if I take it, this angle is 120. Right, gentlemen? And every side is 20 kilometers. This is all 20 kilometers. Now, otherwise, if that side is not same, different sides they have given, the angles are different, then problem is a little bit what you call it as laborious. Now, this problem is simple. What will happen if I draw the perpendicular bisectors also? For example, he has given it in such a way, it is all sides are equal. So naturally all the areas also, can you tell me what will happen to all the areas? All the areas corresponding to each of these rain gauges 5 are same. So even all the areas are same, for example, whatever may the total area, I am not interested. Whatever may be the total area, each rain gauge area, how much it is contributing? 20% weightage. For each rain gauge, what is the area contribution weightage factor? 20%. If I take it, can't I calculate now? Let us see how easily I can calculate. Now, I have taken actually 5 rain gauge stations, the rainfall values. Just now I mentioned, because the sides are same, it is a regular pentagon and the angle is 120. The weightage basically for each of the rain gauge station is same. Because there are 5, each rain gauge station is 20% weightage. So that weight factor is, I have put it as 0.2. 20%. Because how 20%? So this will correspond to 20%, 20%, 20%, 20%, total becomes 100%. That's what I'm doing. I don't know the area. I'm only knowing the weight factor. It is 1/5 of it, 1/5 of it, 1/5, 1/5, 1/5. If the total area is A, 1/5 of A is corresponding to rain gauge station 1. 1/5 is corresponding to station 2. Like that. So if I take the weightage factors 0.2, now what is the contribution for each of this rain gauge? So 60 into 0.2. So this is the contribution for the first thing. There are similarly contributions. If I add all this, what is the thing finally? The average precipitation. How much time you require for it? You require areas to calculate. If you start looking into that angle, then actually what is the figure of it? How to calculate the areas in a pentagon? All that will come into your mind. But that gentleman has not given that. He mentioned all the sides are same. There itself our problem is resolved. And angle is also same. So that becomes the problem easier. Suppose you want to do other way also. Let us not take it in every spirit. So now I have taken the pentagon, you see. I have drawn the perpendicular bisectors also, you can see. And the station corresponding to each of these things also you can see. Right? Now what I have taken, if you want area, each area you want me to calculate how much it comes, then I have calculated that also. I have calculated. using the formulas. See it. I have calculated. So 137.67. So what you need to do? Take the rain gauge rainfall value at station 1 multiplied by the area, station 2 multiplied by the area, station 3 multiplied by the area, station 4 multiplied by the area, station 5 multiplied by the area, and station 5 multiplied by the area divided by the total area. Same answer I will get. But this is all not required. This entire calculation is not at all required. If you really understand, that's why I told the weightage factor importance. Without even calculating the area, you can find out what is the average precipitation. So this is the beauty of this question actually. Now there are different multiple choice questions I have given. Fill in the blanks I have given. Similarly, one sentence answer questions also I have given. Please try them. Thank you. Thank you all.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.